So previously we looked at working with different structures, different formats of text. And one of the things that I pointed out along the way was this idea of encoding the text, so applying a different encoding to the text. Let's take a closer look at what that means. So here's some text. I've just got the word hello and an exclamation mark. And obviously, as far as we're concerned, as humans, that's a series of characters, most of them letters, but there's one punctuation character there. And that represents a word, in this case, hello. Now, computers don't really work with text. They like to work with numbers. So what we can do is we can apply a system where we effectively map a number to each of these characters. So we might have some numbers that look like this. This is the decimal representations, the integer numbers that represent those characters. So quite often when we're working with data, we tend to look at things in hexadecimal representation rather than decimal. So here's the hex versions of those numbers, but they're still numbers. They're still numbers that a computer can deal with. Fundamentally, what a computer works with is bits, binary values of 1 or 0, and we arrange these into sequences of bits. So what we could do is actually translate that decimal representation of the character to a binary representation of the character, and you can see that here. Now, this is actually all a system called ASCII, which is the American Standard Code for Information Interchange. And what that really did was allow us to take text characters, map them to numbers, which then could be represented as binary, and that's something that a computer can work with. Now, ASCII itself is fairly commonly used for basic internet technologies, for passing email and so on around, but it's pretty limited. It only really works with English characters, and it's limited to 128 characters. And obviously, there are many more complex characters in the world that we might want to work with. So there are other ways that we have of representing these characters. So let's take another example here. Here I've got the Greek for hello with an exclamation mark, and I've got that out there in Greek characters. And again, we'll take the same approach. We'll represent each of the characters there using a decimal number. And here's the hexadecimal representations of those numbers. And then we'll encode those as binary. So here we have those binary values representing those characters. Now, one of the interesting things I want to point out here is that Greek phrase for hello actually includes a space here. And that space is obviously just a regular ASCII character. So I can see that that's represented by the number 32, or the hexadecimal 20, or that binary value there, which we've shown it here as 16 bits. Now, there's 8 bits to a byte, so that's 2 bytes. But actually, only the first byte values. Only the first byte actually matters. The value is less than a full byte. And there's a similar thing at the end. We've got our exclamation mark, which again is just a regular ASCII character, and we've got our numerical representation of that. And again, we only actually need 1 byte to represent that, but we're using 2. And that's because of the way that we've chosen to encode this. Some of these characters require more than 8 bytes. They require, more than 8 bits. They require more than 1 byte. So we've encoded them using 16-bit lumps of text, or lumps of binary values, if you like. So 16-bit encodings. And this is an encoding format. It's actually called UTF-16 is what this represents. And it's a way of encoding values where we take 2 bytes, or at least 2 bytes, for each character. In some cases, we might even have to take 4 bytes. We might need to have 2 sets of 16 bits. Now, that's okay in its way, but it's a little bit wasteful. It might be better if we could be more efficient about this. So there are other ways of encoding data. So let's take a look at the same example. Here's the Greek for hello with our exclamation mark. And this time, what we've done is we're using 8-bit blocks to represent each of the characters. Now, in some of those cases, because the binaries, we know the binaries more than 8 bits, we'll actually need 2 decimal numbers not added together, but 2 decimal numbers taken together to represent each character. So in some cases, we've got these, the character 206 and 147 gives us one of those characters. But in other cases, we don't need that. In cases like the space and the exclamation mark, we've got 32 and 33. Or if we look at that in hexadecimal, again, you can see they kind of stand out. Those ones that only require 1 byte have only got 1 hexadecimal value rather than 2. And what that means is when we represent that as binary, we've got a whole bunch of 8-bit bytes here. And some of these have to be taken as pairs. So there's 2 8-bit bytes that represent the first character. There's 2 8-bit bytes that represent the second character, and so on. But for our space and for our exclamation mark, we're only needing to use 1 byte. So we're able to save on a little bit of space there. If we've got a mix of wide characters, as we call them, that require 2 bytes, and other characters that only require 1 byte, we're able to use that variable length format. In this case, it's an encoding called UTF-8, 8 meaning that we use multiples of 8 bits to encode our characters, and that's the way that we represent the data. Now, all of this, you might be scratching your head and thinking, well, this is really getting into the depths of how these characters are represented. You don't really need to be an expert in encoding or character mapping or anything like that to work with data, but it is important, and I'll show you why. So here's my text file that we saw in the previous topic here, and it's a text file that contains some information about my products. And you can see I've got multiple languages in here. So I've got some English descriptions, but I've also got some Arabic and some Thai and some Chinese and some various different languages throughout here. So what I want to be able to do is to make sure that I'm always able to read all of those characters regardless of which language this is in. And this is actually encoded as UTF-8. If I go and save that file, and you can see the encoding there, I'm going to save that. I'll give it a different name, so we'll call this products2, and I'll give it a different encoding. I'm going to use something called the ANSI encoding, which is slightly confusing. It's actually a Windows-specific encoding. So I'm going to go ahead and save that. And I get a little warning here that this contains characters in Unicode format, which will be lost if we save it as an ANSI encoded file. So we'll go ahead and do that anyway. We'll just ignore that warning. And I'll close down this version of the file, and I'll just open up that new one that I've created. And you can see that I've lost some character information where we weren't able to get the right data because it's in a different encoding. We've just got question marks here that represent those characters that we don't know what they are. So that's why it's important to know about encoding. When you're working with data, you need to be able to make sure that you're reading and writing using consistent encodings so that you don't lose any data along the way.